For this next example, we have another integrand where setting the denominator equal to u and then writing du would not give us what we needed in our numerator here, so we're going to again use partial fractions. So first thing I want to do is factor this denominator. When I factor this, I can pull an x out of everything, which gives me x squared plus 2x minus 3, which factors as x plus 3 times x minus 1. So that tells me, since I have three linear factors here, that I'm going to have three different fractions with my partial fraction decomposition here. So I'm going to have something over x plus something over x plus 3 plus something over x minus 1. Okay, so again, I'm going to come over on the right to do the algebra part. So rewriting this, I get 4x squared plus 13x minus 9 over those factors, okay, is equal to, excuse me, a over x plus b over x plus 3 plus c over x minus 1. And now I'm going to need to solve for all three of these factors here, okay? Multiplying everything by all three factors will cancel out all of these. So I'll have 4x squared plus 13x minus 9 left over. And then on the right side, here my x cancels, and I have x plus 3 times x minus 1. Here, x plus 3 cancels, so I'm multiplying b by x and x minus 1. And then here, x minus 1 cancels, so I'm multiplying by x and x plus 3. Okay. So I'm not going to distribute this time because I'm going to show you another method for partial fraction decomposition. Okay, so instead I'm going to leave the a's and these terms factors. So we'll have a times x plus 3 times x minus 1 plus b times x minus 1 plus c times x plus 3. Okay, so remember with the last method that for this first example that we used, we wrote one equation using all of the x terms, just the coefficients, and then another equation using the constants. That would work again here if we distribute all of this, but again, we're looking at a second option, and it does not matter which one you prefer. So what I'm going to do here is I'm going to plug in values for x and write the remaining equation, okay? And that will help me solve for a, b, and c. So the values I'm going to pick are the zeros of these three factors, okay? So for the first one, we're going to say let x equal 0. Okay, if x is equal to 0, the left side of my equation is, let me move this up here for a second, is 0 plus 0, oh, that's not a 0, 0 plus 0 minus 9, okay, equals a times, and then I have 0 plus 3, which is 3, times 0 minus 1, which is negative 1, and then plus b times 0, so who cares about the rest of it, plus c times 0, who cares about the rest of it. So I end up with negative 9 is equal to negative 3a, meaning that a is equal to 3. Okay, so plugging in x equals 0 got rid of my b and c factors, and so I was able to solve for a. Okay, then I repeat that process. Now I'm going to plug in negative 3 for x, so x equals negative 3. So we have to do a little bit more arithmetic here. So 4 times negative 3 squared is 36, plus 13 times negative 3 is negative 51, minus 9 equals, and so now I have a times negative 3, who cares, that's 0, all right, plus b times negative 3 times negative 4, negative 3 minus 1, plus c times, that one's going to be a 0, so again, a 0 here. Okay, so solving this, I have 36 minus 60 is negative 24 equals positive 12b, so b is equal to negative 2. All right, then repeat one more time with x equals 1 to solve for c. So if x equals 1, we have 4 times 1 plus 13 times 1 minus 9 equals a times, doesn't matter because this is a 0, plus b times, doesn't matter because this is 0, plus c times 1 times 4. Okay, so 4c here. So now we have 4 plus 4 is 8 is equal to 4c. So c equals 2. Okay, so now plugging these values into my numerators for my fractions, I get 3 here. Again, make sure you put the right numerators with the right denominators. A negative 2 here and a positive 2 here. And now I have 3 fractions that I can integrate with some pretty straightforward natural logs. So I get 3 times the natural log of absolute value x minus 2 times the natural log of absolute value x plus 3 plus 2 times the natural log of absolute value x minus 1 plus c. And if I want to combine this into a single log, okay, let's use some log properties here. This 3 comes up as an exponent. This 2 comes up as an exponent. This 2 comes up as an exponent. So I have the natural log of the absolute value of, so this is going to be x cubed. This one is going into the denominator, x plus 3 squared. And this one is in the numerator, x minus 1 squared, all right, plus c. Okay, so that's another method for partial fraction decomposition. I'm going to pause here and I'll be back.